Okay, let's get into some trig integrals now. So here we see some functions, possibly a composition, but here I see cosine is being raised to the fourth power. So for me, I'm going to start by saying u equals cosine x. Then du is negative sine x dx. So we see here that we have a sine x dx, but not a negative sine x dx. So we need to divide by that negative. Negative du equals sine x dx. So now we can use substitution. I have negative integral of u to the fourth du. So this is negative 1/5 u to the fifth plus c. So that's negative 1/5 cosine to the fifth x plus c using u substitution. So now, looking at number 6, same kind of idea, but keep in mind, right, that if we're going to have trig, like u, the derivative sine u, or sine x, better said, needs to be somewhere there, and this isn't happening here. So what we can do in this problem is use a little trig identity. So we can break this down to be cosine x multiplied by cosine squared x dx. And then we use the identity that cosine squared x is 1 minus sine squared x dx. So now, if I look at this problem, I can see that sine is being squared. So I'm going to let u equal sine x, and then du equals cosine x dx, which is happening here, right? Cosine x dx. So now this becomes the integral of 1 minus u squared du. So the antiderivative of 1 is u. The antiderivative of u squared is 1/3 u cubed plus c. And then u was sine. So this is sine x minus 1/3 sine cubed x plus c. So that's a little trig identity trick that we can use in these types of problems. So now let's go ahead and jump into number 7, right? We need to rewrite this in a way where we can possibly do u sub. So to me, this is the integral of of e to the 1/3 x dx. So the composition function here is this 1/3 x. So we can let u equal 1/3 x, du equals 1/3 dx, or 3 du equals dx. So this becomes 3 integral e to the u du. And this one's easy. Antiderivative of e to the u is e to the u plus c. So this is 3e to the 1/3 x plus c. So u substitution is helpful when we see compositions of functions and some form of their derivative in the answer.